Okay, I was reading this article on Sector ETFs on Nasdaq.com, and it lists a lot of the best ETFs. I think they're the largest. Yeah, the biggest ETFs, exchange traded funds in each sector. It lists 4 of them in each sector. So I thought it might be interesting to form a portfolio with all these and see if we can optimize that portfolio using Excel Solver. So what I did, and I went to Excel. Let me go ahead and paste this article in here. So what I did, I went to so this is the website, and what I'll do is I'll when I'm done with this file, I'll leave a link to it in the description of the video. So if you want to download it and look at it. So anyway, so these are the stock tickers for, we have technology, healthcare, financials, real estate, energy, materials, consumer discretionary, industrials, utilities, consumer staples, and telecommunications. And when I did it, one of them, I was using stock history on Excel to download it because that seemed pretty simple. So I was missing, I couldn't get one of the real estate tickers, so I only have 3 for real estate. But the way you use stock history, you have to tell it what day you want to start. So I go equals today minus 300 a year and a day. So we'll start 320, and then we'll go, and then the end date for the stock history one, we'll just go equals today. So that way, if I come up here in a month, if I go back to this website in a month, or back to this file in a month, it'll update it automatically. I'll just go get a year. We want to get a year's worth of daily data. So I'm going to go equals stock history. And I want this stock, and I want this for the start date, and this for the end date. And this is a spill function, so I'm probably going to get an error because I just put this down here. I didn't realize, I forgot I did that. So I'm going to have to, so I'm going to get an error, but then I'll remove that. So I have to move this. I'll just go ahead and do, I'll delete it. You can search for it. Just search 11 sectors. Go to the Nasdaq and search for that if you want to. Nasdaq.com and search for it. So I'm going to delete it, and then it spills down. So these spill functions, if you have something in the way, it's not going to work. All right, so these are the close. I wish it would do like adjusted close, but I don't think the ETFs normally have adjusted close anyway, so it should work. You can see it's a spill function, but I see all it's highlighted in blue. And then we'll do the next one, and on the next one I don't want the date, so I have to do it a little bit different. I'm going to go equal stock history. I want this stock, and then I want this start date. I'm going to go ahead and F4 that because I want to copy that across. And I want this end date. I'm going to F4 that also. Because that way when I copy this formula across, it'll still stay on those 2 dates. And then you have to do it this way. If you do it that way, then, comma, 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 1, then it won't put the dates, and we don't want the dates because we just need the dates once. We can scroll this all the way across, and we have all of our daily close prices for each one of these exchange traded funds. Okay, so let me go ahead and this is a lot of days, so let me hide a bunch of these columns just so we don't have to look at them. They're there. We're just going to hide them. So I just jumped to 5 to 2050. So we could call this sector ETF daily prices, something like that. So let's do another. We're going to do another one. We'll create another spreadsheet. We'll call this returns. And let's just go ahead and get these headings. Shift and right. Get all these. Well, we'll go all the way. And then we'll go Control C to copy them. And I guess for the returns, we'll just start them here because I want to do some other things. So I'll start them right here. And for the return, it's going to be equal to, the daily return is going to be equal to the sector return. And we want to do, so we want to go October 1st, 2020 divided by the day before minus 1. So that'll give you the daily percent return. Now I'm going to lose a row because I don't have 929, right? So when you do returns, you lose one row. And I noticed down here, the last day we're missing some. We can't really use this for calculations because some of it has some missing data. So I can't use 930. So I can only go down to 929. So anyway, I'm going to go ahead and hit enter, and we can drag this down. And so we have to be careful here. Let's go ahead and put these dates. I'm going to start with 10-1 because copy. I don't know if this will work. I'll just paste the values. Okay. So we can only go down to, oh, I guess that's pretty good, didn't I? So we only want to go to 929, and I did exactly. I don't know how I did that. That was very lucky. So we just want to go that far because remember, we can't use the return for 930 because this would give you a 100% negative because we don't have. So we can only go to there, and then let me copy this across. And then copy, and then let's go ahead and change it to percent. And then I'm just going to double click this to send it down. Okay, I won't send it down because what I got to do, I have to go. I can't include this first column. Got to start there. Double click and send it down. Okay. All right, and then so now we have all the percent returns, the daily percent returns, starting from 10-1 all the way through that many. All right, so let's go ahead and hide. Again, let's hide rows because we don't need all these rows. We get the idea just by looking at a few rows. And so let's do some summary statistics. So we'll do something called the expected return of each one of these, and that would be the daily average return. Okay, and so that's pretty easy. We can just go here. This auto sum is a good way to do the average. I can go down here and just say average. It automatically does it for me. And we can copy that across. I guess we can copy all these across when we're done. And then the next thing we want to do is we want to do the standard deviation, which is a measure of risk. So I'm going to insert the symbol for standard deviation. It's pretty easy to do. And that's going to be equal to the standard deviation. We want to use a sample standard deviation. And we want to make sure we don't get the expected return when we do it. And that's also, the standard deviation is also in percent, so we can copy that format to that. Okay. And then we do the count of them, how many there are. So I'm going to go equals count. How many observations do we have? We want to count all of these observations. So there's 251 observations. And then we want to do, we'll do the expected return divided by the standard deviation, which would be a return per unit risk. You could call it like a modified Sharp. Okay, so that's all that's going to be. Is we're going to take that divided by that, right? So this is going to be a number. It's percent divide percent, so it doesn't have any units. The units cancel out. So that's our modified Sharp. So now we can just drag this across and do all these. Oh, let's do one more. Let's do the variance. The variance is actually the standard deviation squared. I can just copy this. put a 2. Okay, so the variance is actually just going to be equal to standard deviation squared. And that one, we don't need quite so many, but that's not percent because it's percent squared, so we'll just leave it that way. And then let's just drag this across so we have it for all of these. And those little pound signs mean we need to auto fit, so I'm going to go ahead and auto fit. And then I don't know how these got this weird format. Let's make them all the same. Alright, so now we have all the summary statistics. And so the next thing we're going to do something called the excess returns. And I'm going to call that X. We'll call that sheet X. And the excess returns, basically, let's go ahead and just let's go ahead and copy this header again. And so the excess returns are pretty simple. It's just going to be equal to each return. Subtract from that its expected return, which is that. So I want it to stay. Everyone I want it to subtract this from this, this from this, this from this, this from this. So I don't want it to move off of this. So this I should say I'm going to hit F4 until I have a $ in front of the number, right? Because I don't want it to go. I don't want to move. I don't want that average return to move when I copy the formula down. But I do want it to move right and left because I want it to move to the next. I want it for VGT. I want to use that average return. For FDN, I want to subtract the average return for FDN. So I just put the $. I make the rows absolute, but I don't make the columns absolute. And then we can copy that down. I guess we should get those dates again, right? So we get the right a number of them. Copy. You go up here again. Let me insert the date as a value. Okay, so now we can copy that down as far as we need to. Actually, I could just send it down now. Right? And then we can copy it across. And let's go ahead. We've got to pick from here to send it down. And we'll send that down. And then what I'm going to do while I'm here, I'm going to highlight it all. And I'm gonna go up here. I'm gonna use that in the formula editor, so I'm gonna call that X, right? So excess returns X. So now, no matter where I'm at in a formula or whatever, if I go equals X, it's gonna go find that, right? So it knows what X is. It knows it's those. Like if I could even go here, I can go to X, and go here and go to X. It automatically goes. So it knows those are all my excess returns. Because I'm going to use that later in a formula. Alright. So the next thing we want to do, we're gonna create something called a variance covariance matrix. Okay? And the variance covariance matrix. So we're going to use the same. Whoop, there's my sheet. We're going to call this let me move it to here. So we'll call this var covar. And let me go ahead and, to save time, I'll copy and paste here a little bit. And then, so we have to var covar. You're going to transpose the. You repeat everything and transpose the titles like that, right? So we have the sectors this way and the sectors this way. So we're gonna highlight everything here, and we're gonna fill everything in here, we're going to fill it in with the variance covariance matrix. So you have to highlight it first. And if you see this little formula up here, it has what we need to do, and I'll show you that in a second. Before I do that, I'm going to go back to returns. I'm going to call this I'm going to call that small n. We're going to use it. How many there are, how many returns there are. So now let's go back to the var covar, and I'm going to start typing. I'm going to go equals and multiply, and it's going to be x. Well, it says, if you remember the formula, first we have to transpose the x. That's what the little t was for. Then I have to take it times x, and then you're going to divide it by n minus 1. Okay, and I spelled transpose wrong, so you have to put an s there. Right? Now, when you're putting in a matrix formula, you just can't hit enter. You have to hit control and then shift and then enter, and it puts all your numbers in there. Okay, so we can check if it's right, because this 0.0, these diagonals here, all these diagonals, they're the variances. Okay, so those are the variances. So that's why I did the variance back here, so we can check. So 0.0155, 0.016, are those the same? 0.0155, 0.016, 0.0027. So you can see that those are the same. And then the covariances are here. So the covariance between XLT and VGT is 0.0156. So you can see it has this twin here, because it doesn't matter which direction, they're the same. So they all have a twin. So you have like an upper triangle or a lower triangle. So this is called the variance covariance matrix. And why we're doing this will make sense in a second. But I'm going to go ahead and I'm going to highlight all these, because we're going to need this later. And I'm going to call this var covar. Okay. So we're doing things slowly but surely. Now, what we could do, an interesting to do, we don't have to do this to optimize a portfolio, but it is interesting to do the correlation matrix. So we'll do that right down below. And the correlation matrix is going to be, let's see how far this goes to the right. It goes to AS. Okay, so I'm going to go down all the way here, and I have to go all the way over to AS. That gets them all. Oh. And then it goes to 94, and then AS. If you do it this way, you can't really see. So that's what you want. But the reason I'm doing it that way, because I want you to see the formula as I type them in. So this is the correlation matrix is equal to the square root of the var covar. We just called it that, right? See how it highlighted that automatically? Divided by m multiply and it's going to be the transpose Well, before I do that, first of all, I have a typo here. This shouldn't be the weights. This should be the standard deviation. So let me put the symbol in here. So it should be that. I guess when I'm typing this, so let's go ahead and we'll go back to the returns. So let's go ahead and call these standard deviations. I guess we could call them STDDEV, standard deviation. Okay, so now we can do, now let's highlight this again. So it's 94 to AS. So we'll go down here, down to 94, all the way across to AS. And then, so I'm going to put this in here. So I'm going to go equals m multi, that's going to be the equal to the square root of the var covar divided by transpose. And we're going to multiply, m multiply the transpose of the standard deviation. That's what we just called it, right? And that's going to be times the standard deviation. And then we're going to close that. And then close the square root. Then we go Control Shift Enter. And we know we did it right because it has ones here in the diagonals. So it correlates exactly at 1 to itself, right? I don't know what these little ears are here. Just, I don't know. I probably need to look into what's causing them. But we know it's right. It's probably dividing by 0 or doing something and it's causing a problem. But anyway, so there's our correlation matrix. So what's interesting when you look at this, so when you're trying to diversify, you want sectors that don't correlate very well. So right here you see this energy and the technology. If you look here, let me highlight that some color, maybe highlight it blue. You can see those correlations are relatively low. If they correlate perfectly, that's 1, right? So those two sectors correlate don't correlate together very good. You can see other sectors like healthcare. Well, that's healthcare and healthcare, of course, they correlate. So anyway, lower, you want to look for, when you're diversifying your portfolio, you want to look for, you're not going to get the benefits of the diversification if it's 1, because one goes up, the other one goes up, one goes down, the other one goes down. So they might as well, they act like each other, right? So there's no reason to do it. So you're looking for lower correlation. So that's why I did the correlation matrix. Although you don't even need it, because we're going to have Excel pick it out for us, right? So you really need this to have Excel pick it out, but just to see what's going on, it's kind of nice to look at the correlation matrix. All right, so now we'll go to sheet 5. We'll do our portfolio optimization now. Okay, so what I'm going to do, I'm just going to see if this works. Well, let me just do it this way. So we'll do our summary. And I'm just going to do, we have it horizontal over on the return sheet. Let's just go ahead and make it vertical. So I could say this equals transpose. Don't forget the S in transpose. Okay, equals transpose. And we want to transpose all these returns. I'm just going to go ahead and put all those in there. Close the parentheses, Control Shift Enter, and we can make that %, take it out a few places. So now we have all the returns, and then we already typed this in, right? So we already did the standard deviation, so I could say this equals transpose standard deviation. Close the parentheses, Control Shift Enter. And then we went ahead and go ahead and make those also %, take them out a few places. And we can just calculate this. This is equal to this divided by this. And that's a unitless number. And let's go ahead and copy that down. Auto fit it. And I like to do, so let's just highlight all these and make them look nice. Go ahead and wall borders. And what I like to do, I like to highlight these. I like to use conditional formatting. So I want to know the sectors that have the highest return. So I like to go to conditional formatting. I'll go top 10%, and let's make them green for good. So those are the top 10% return ETFs as far as their average daily return. And then risk is bad, right? So we want lower risk. So I can conditional format that. I can go bottom 10%, and also lower risk is good, so I'll make that green also. So that's the lowest. Those are the lowest risk portfolios, the lowest. And then this we want green is good if the Sharpe ratio is high. You want a higher return per unit risk. Again, I'll go conditional formatting. We want top 10%. Again, make it green. Okay, so now we can kind of see our portfolios, and we see that we have low risk. We usually don't have high return. We have high return. We usually don't have low risk. Here's one where we have a high return and a good Sharpe ratio, so that might be a good one for the portfolio. But a lot of times you're very rarely seeing that the return. Very rarely you get a lower risk and a top 10% risk as far as good low risk, lower 10% I should say, in the top 10% return. So maybe Excel can help us out here. So maybe let's just try first. Let's just do an equally weighted portfolio, right? So let's do. To save time, I'm just going to go ahead and put this whole thing in here. So we could do an equally weighted. Okay, I can't do that. Nope. Cancel. Escape. Can I get out of that? Aye. Blah. Okay, so I don't want that though. Control Z. Alright, I just want to I'll copy the values. Copy the values. Okay. So here's our sectors, and so what I did is I did the weight. The weight is just 1 divided by the count instead of just counting them. So it's 2. I'm gonna put if I had $1,000, I put $200, or I put $20.33 in each one of these, right? And then I would have my I have equal amount of money put on each one of these sectors. So I just use count. I think there's 43 of them, but I just use count just to and then what we want to do, we want to sum these. So I'm gonna get this should be equals formula text. Okay, and so I want to sum these, so I'll just go ahead and hit auto sum, and they should add up to 100% if I equally put them out in each one. So the next thing we can do, the expected return of the portfolio, and that's just going to be equal to, I'm going to do the easy formula, it's equal to the sum product of all my weights. It's like a weighted average times all my returns. So I'm going to go ahead and F4 that return, so if I copy this around, it'll always go to those returns. And then so that would be the return in the portfolio is 0.11, which is a fairly good return. And then we could do something called the standard deviation of the portfolio, and I'm going to use this little formula that we have right here. It's going to be equal to so let me make that formula look a little bit better. So I didn't use this formula here. Right here. Let me copy these down because okay, so I use sum product. So you could also try it this way, but I use sum product instead. That's a little bit easier. So now this one we're going to use the weight transpose. So I'm going to go equals the square root of m multiply times the transpose of the weights okay times the variance covariance matrix. Okay, so that's 1 m multiply, and then I have to multiply it again. So I'm going to go to the front. I'm going to go to the front here, m multiply, and then I'm going to take it times the weights again, but not the transpose weights. And then I'm going to close the parentheses and close the square root. Control Shift Enter. And the problem is I spelled transpose wrong, so there should be an S in here. Control Shift Enter. and the portfolio return is 0.859. Okay, so that's the way to do it using matrix multiplication. Now remember, you got to hit Control Shift Enter when you do that, and then this is just going to be equal to this divided by this, right? So and then of course again that's not a percent, that's a unitless number, the modified sharp. Okay, I call this modified. Okay, so what did we see here? We've got a risk of 0.859, which is fairly low, right? The lowest risk we have here. Here's 0.839, so we got like a fairly low risk. And we got a fairly good return of 0.11, which is higher than a lot of these. Some of these even had negative returns, right? So it's we got risks that's almost as low as the 10%, almost as low as the top 10% as far as risk, and a fairly good return. But we didn't make Excel do any thinking there, though, did we? We just made it. We just did it equally weight without any thinking. So let's try another one. So I'm going to take this. I'm going to copy this, and we'll do instead of equally weighted, let's go ahead and we'll maximize the return and hold it to the minimum. We'll hold the risk we want to have the risk to be as low as the lowest risk that we had out of all of our individual ETFs. Our lowest risk is 0.693, right? So that's 0.672. Where's 0.672? Oh yeah, 0.672 is the lowest risk, right? So we're going to try to hold it. We're going to try to maximize our return. We're going to try to maximize this, but hold this to this or lower. So now I'm going to show you how to. Now we're going to do the fun part. Now we're going to have Excel change these weights and try to do that. So I'm going to go in here. I'm going to go to Data, Solver, and so I want to. My objective is to maximize this return, right? By changing these weights right here. And we want to add some constraints. We want to say that this standard deviation needs to be at least lower than my minimum standard deviation of all my others. And we also have to add another one. We have to say you have to add up to 1. Use 100% of the weights. And go OK. And then we can solve this. So far it's got it up to 9%, it's saying. This objective cell, where you read that, it says it's got this return up to 9%. And then I'm going to take that solution. So it found, let me take that out one more place. 0.089% was a return, and I got it down to that 0.672. So let's do this. Let's highlight these. And I'm going to go back to conditional formatting. I'm going to say if it's greater than 0, I want to make it green again. So this is where it tells you to invest your money. So it says it likes you investing in the healthcare sector and the consumer staples. It's got 3 of those, right? And some of the sectors it's not investing at all. Energy, utility, consumer discretionary. So remember, this is using historic data, right? It's just using, the daily data for the last year. So we don't know for sure if that's what's going to happen in the future. In fact, we don't, this totally avoids anything to do with what's going on with the economy or, any kind of systemic risk, right? It's just looking at, all we're doing is looking at the history. So So anyway, but it's still kind of interesting to do. So you'd put your money into those highlighted portfolios. If if your only goal is just to modify or to get your standard deviation that low, the lowest out of any of my single investments. So it's kind of interesting because the Sharpe ratio is 0.132, and actually brings the Sharpe ratio into the top 10% of the Sharpe ratios, and I got really low risk. So that's just showing right there the benefit of diversification. I've got a really good Sharpe ratio, and I got my risk as low. My Sharpe ratio is in the top 10%, and I got the risk as low as the lowest one out of all of them. So just by diversifying without spending any money, I was able to. That's why they call it a free lunch, right? Diversification's a free lunch. All right, so let's do another one. So I'm going to copy this. Let me go over a few more again here. I guess I can go here. Paste. Let's delete some of these cells. They're taking up a lot of room. Okay, so now what we'll do, my next one, what I want to do, let's just minimize risk totally. Okay, so I'm just going to say minimize risk. And so if we're just going to minimize risk, all we're going to do is let's go back to Solver. So I like to reset Solver sometimes. So I'll go to Data. I'm going to go to Solver. Let's just reset all and start again from scratch. So now what we want to do, our risk is right here, right? The standard deviation, the portfolio standard deviation. I want to minimize it by changing these cells, right? And we're going to say the only constraint we had to have, we still have to have this add up to 1. And that's all we want to do. We just want to minimize risk, and that's our only thing. The other one, we tried to just hold the risk to a certain level, right? So now we're just going to try to minimize it. So I'll go solve. On 2, they could be any number. They could be 0.2, anything like that. So it's doing a lot of work. All right, so here's what it did. The portfolio changed a little bit, right? It stuck to some of them, but it did change it a little bit. And it got the risk went from 0.672 down to 0.632. We really took a hit on our return, our expected return, and we really took a hit. We almost halved our Sharpe ratio. So, but if you're really risk diverse, you could try that. I'm gonna do one last one. Let's do this is probably the more interesting one. We'll maximize the modifier. I call that modified Sharpe. Okay, so I'm going to go ahead. I'm going to go to Solver again. I like to, like I say, reset all just to make sure you don't have a problem. So now we're going to maximize the Sharpe ratio down here by changing these weights. And we're going to have to add the constraint where they add up to 1 again. And we will go solve a little bit, but there we go. Okay. So now we got a really good expected return. If you look, it went from the return almost tripled or over tripled. And my risk went up a little bit, but I got a triple return and I got a really good Sharpe ratio. And so the Sharpe ratio is better than any of the Sharpe ratios of any of these, right? Yeah, so we did very good there. And our risk is actually, if you look at the level of risk, the risk is pretty good. It's only 0.632. And, oh no, that's the wrong one. The risk is 0.919, right? So, but it's still not too bad. I mean, 0.813 is within the best 10% as far as risk. So 0.919. So anyway, that's just a little interesting thing. So if you do it that way, you're fairly well diversified, right? You have money in technology, healthcare, financials, real estate, energy, consumer staples. So you still diversified quite a bit. It looks like you put most of your money in healthcare and financials. That's enough for this video. So anyway, hopefully that was interesting. If you like this video, my picture will come up. Click on my picture to subscribe. If you haven't subscribed already, give me a thumbs up. Give me any comments. So hopefully that was interesting to you. Thank you.